welcome everyone to this session. I hope most of you are able to enjoy their lunch. And this session will be about backward compatibility, because I think it's one of those topics that we don't talk about it a lot at conferences, in blog posts. Like, it seems something that is always a given or it just works. There are a couple of tools there for certain data stores. Think of FlyWayDB, for example. But like, judging this from an application perspective is something that is not really often done. And it's just a topic that I'm missing because not all of us are doing greenfield development. I think it's a rather small percentage, to be honest. And this is the reason why I would like to talk about that. And I will use Elasticsearch as an example. It's the code base I'm most familiar with. So hi there, I'm Alex. I work at Elastic. I'm part of the community team nowadays. I used to be part of the Elasticsearch development team. So if you have any questions, just go ahead, drop them into the chat, even if they're not talk specific. I'm happy to answer them later. And yeah, let's go on and talk about a couple of things. So what I want to talk about today is that, how Elasticsearch deals with backward compatibility. Things get more complex when you have a distributed system. Maybe you're lucky and you do have a stateless system, so then complexities reduce a lot. But what I'm after here is that you basically start to think about your own services and how to provide backwards compatibility guarantees and help also users to upgrade. So one of the things is, even with the introduction of more microservices in your own infrastructure, you will have seen that you have to provide some sort of guarantees to the other services talking to you. So you are potentially already in the middle of a distributed system, even if you don't use something like Elasticsearch in there. So as you can see here, Elasticsearch is right in the center of things. It's kind of the heart of the Elastic stack. You see Kibana at the top, which is kind of the management and monitoring UI, which means it's on the one hand executing a lot of search queries against Elasticsearch, on the other hand, a lot of administrative APIs. You have the two components down there, which are responsible for ingestion, which also means that they need to be able to send data constantly, no matter what the Elasticsearch version is. And you don't want to shut everything down in order to execute an upgrade. So again, we have to provide some sort of compatibility there. And I want to talk about that as well. Like, the hardest compatibility usually is at the edges of systems. And of course, all the three solutions are basically using parts of the stack. And the last part at the bottom is also important when you talk about backward compatibility, and that's the deployment option, right? When you use a software as a service, you don't usually have to care so much about this. You rather have to care about your own application. Sometimes you have infrastructure which eases the upgrade, like Kubernetes, and you can just kind of trigger a rolling upgrade in there. But if you run everything on premise, things may become more complex than running this in existing orchestration tools. So yeah, the stack here, or Elasticsearch, is right at the middle. Describing Elasticsearch in 1 minute is potentially the most common thing is that it's a search engine. You can do like the classic full text search. Think of Google. You type in a term in the search bar, and you get back the documents that are matching. There is the possibility of doing analytics, which is more of a business intelligence use case if you want, and also geosearch. So Yelp is maybe a common example. Give me all restaurants which are 5 minutes walking distance from here. And you can combine those in an arbitrary way. Elasticsearch is near real time, so the time spent between indexing data, making it available for search, should be as small as possible. It's a distributed system, and this brings its own complexities on top there, just to make sure that even without Elasticsearch being communicated with external systems, we also have to make sure it's compatible when it talks to nodes within the cluster. It's scalable, so you can basically scale it up, scale it out, buy bigger hardware, or create more nodes. It's highly available and resilient, so it kind of figures out by itself if there's an outage of a node, and moves data around as needed, for example. The interface is HTTP and JSON. The reason for this is simple. The protocol and the object notation are both pretty known in the development world, so users kind of feel more home from the beginning. So let's take a step back and talk about what backward compatibility is, or what you need for this, and why we need it. So one of the things is, if you do an upgrade, and maybe a rolling upgrade, you need to run different versions in parallel if those components communicate with each other. The same applies for your web application if you do a rolling upgrade, right? Like, they're potentially running different versions, and they need to adhere to a certain standard of communication to make sure everything is working as expected. You also usually would like to run upgrades without downtime. Downtime used to be a thing like 10 years ago, but with modern infrastructure and with modern tools, we try not to have any downtime no matter what we do, be it upgrades on the tools that we use, be it upgrades on the underlying operating system. We usually try to be able to update parts of our systems without having any downtime there. And this also means that there's, again, a mixed version running. Also, one of the things you would like to have is reduce the version dependencies between client and server. So if you have a certain client communicating with a server, you want to make sure that you can upgrade each of those independently and things are still working as expected. And that there can also be a delay in there and you don't have to upgrade everything at the same time, which usually means it's more complex to orchestrate your whole upgrade process. So you just try to make it less brittle by having less dependencies in there. So what kind of complexities do we face here? If we take a look at like the different deployment models that I mentioned earlier, the best thing that can happen is software as a service, right? Because if you're running a software as a service application, you usually have a very defined interface of communicating with your clients. If you have a web application, it's your browser. So you just ship out some HTML. But everything behind that is in your control, and you can kind of decide of how you run your upgrades. So this is one of the better cases if you want. If you provide an API to third-party users, it's kind of okayish. Think of all the AWS APIs. They usually come with a date timestamp in the URL to indicate how old a certain API is. And then you can just kind of time this out over time. If you create a new API, you just have to create a new endpoint and let all your clients point to that. And at some point, you can switch out the old one. If you use on-prem software, you just install software locally, you're kind of responsible for all of the upgrading steps, including the operating system upgrades I just mentioned. So this is just a lot more time consuming and requires a lot of planning compared to the other solutions. But on the other hand, running the software on-prem may be cheaper. So calculating this in means you need to keep the total cost of ownership into mind. And this brings us to another interesting question, like why should users upgrade? Well, number one reason for me is security. Like if your software is affected from a security hole, one of the things you should really do is upgrading. Of course, you can always check, is the way you use the software affected by the security hole? That might make sense. But you should always strive to stay up to date just because of that. The next thing is bug fixes. If the software fixes its behavior and suddenly a feature works as intended and you get the correct answer to a certain question, then this is definitely worth upgrading as well. Then you get potentially new functionality. That's an appealing reason as well. If it solves a certain use case you have and it didn't work before like that, then upgrading the software might make sense. And of course, sometimes you get free performance fixes, right? You just install the same software and suddenly you're able to do more operations per second, or you need less hardware and so running it becomes cheaper. So those are rather compelling reasons to upgrade. And they kind of have a different motivation if you want. I do know users who are still running an Elasticsearch cluster from 6.5 years ago because it just is doing its job. They don't need new functionality. Performance is good enough. And it runs shielded, so they don't care for bug fixes and security, no matter how much I tell them that it probably makes a ton of sense to upgrade 6-year-old software. And the motivation here is kind of voluntary. I think it's more of a functionality and performance perspective, or it's kind of forced because you need to keep up to date to make sure that your business is not at risk when you when you upgrade because of security or bug fixes. And I think the willingness of upgrading reduces the more voluntary an upgrade path is, and the harder it is, of course, overall. So this brings us to the next question, like what blocks users from upgrading? And we can pretty much sum this up to a single point or group this together. This is usually changes that are breaking the backward compatibility. So that change the behavior of the software when you install one version to the other. And also the amount of work you need to invest to pretty much fix this. This could be a protocol change. So in terms of Elasticsearch, if we change the JSON DSL and we remove a parameter and suddenly a query that used to work on the old version doesn't work on the new version, this means the user is blocked from upgrading until this parameter has been removed on all client applications. Also, functional changes are a good reason, right? The worst thing that can happen is that a feature gets removed. Then you probably do not want to upgrade because you're relying on this feature or your business relies on this feature. And of course, there are also behavioral changes. We talk about that a little bit later as well. For example, if you upgrade and suddenly you're not able to read data that is older than a certain age or has been written with previous versions of your software. So one of the things how you can indicate if everything keeps working as expected or not is usually the semantic versioning. I have 3 sample versions here, and you can put bug fixes into any version. We at Elasticsearch or at Elastic try not to put features into a patch release. So you know that if you upgrade a minor version, that's the only point in time when you basically get new features. And the only point in time where Elasticsearch should do backwards compatible or break backwards incompatible changes is when we switch between major versions, so from 7 to 8. This doesn't mean that we don't prepare the user properly for this, but this is the only point in time when we really would like to do that. And of course, if possible, you still try to prevent that, but at some points or for some things, you have to do this. And this is where major versions basically come into play. So the question here now is like, what can we do to kind of prepare the user for upgrades to make sure that the upgrades are as smooth as possible so that the user doesn't have to worry about this? So of course, there are different kinds of upgrades. The one that people used to do 10 years ago, I already mentioned it, is the full restart. You just shut down your stack, replace it, bring it back up again, or your software, and everything works. This is invoking downtime. It's something you try to prevent. Early versions of Elasticsearch or early major version upgrades of Elasticsearch, this was the only path forward. You had to do a full restart. So you had to basically put your cluster out of service and then bring it up again. Nowadays, you don't need to do this. You can do a full cluster or a full major version upgrade without downtime. And this would be a rolling upgrade. So you basically shut down one node, upgrade it, bring it up again, shut down the next node until you've done this with all of your nodes. And of course, this brings us back to the question, like, what about clients communicating with your system? Like, how do they know that they require upgrading? How do they know that they require a behavioral change so that the upgrade of the server software is working as expected? And before we dive into that, I want to quickly talk about compatibility guarantees. And for example, from an Elasticsearch perspective, one of the guarantees we give, because this is what the underlying library that stores the data, Apache Lucene, full text search library is doing, is that you can basically read all the data that you have written with the previous major version. So the current version of Lucene is 8, and you will be able to read any index that has been written with Apache Lucene 7. But this also implies that if you have data that is older and has been written with an even older Lucene version, there's no guarantee that this file can be read. And that's something you have to take into account. And for Elasticsearch itself, Elasticsearch uses 2 protocols to communicate. It uses HTTP on the outside with all the clients, and it uses a node-to-node communication, a binary protocol on the insides between the nodes. The reason for this is that we basically try to only send binary data back and forth and reduce the amount of data we are sending, like sending a variable long. I'm going to talk about that in a second. And also don't rely on HTTP as a protocol, because a couple of specifics is something we don't want to deal with in a node-to-node communication. And there's one trick that you can actually pull. So if you say that you can do an upgrade from version 6 to version 7, then you can also say you need to have the latest 6 version, like 6.8.13 in case of Elasticsearch. And this one is supported to work with the latest 7 version, like 7.9.3 at the moment. And with this, you can basically reduce this compatibility matrix down to only 2 versions. And this simplifies your upgrades, but you can still guarantee that you can actually upgrade your older minor or major version to the next one. So let's dive into a little bit of code just to explain some concepts. For example, the node-to-node communication here. There's a dedicated object. It's a stream input and a stream output. This is basically the way we write data to streams, and then those streams get sent to the nodes. And you can see here that has a couple of helper methods, like you can read a Boolean. A Boolean is written as a byte over the wire. That is either 0 or 1. You can read a long variable. This one is a vlong, so it's a variable length encoding, which means if min.count is a small number like 0 or 1, we don't need to write 8 bytes of data over the wire. We just write less bytes. And the interesting part over here is this one. So in the custom node protocol, we basically have the ability to read the version that this data was sent with. And in order to make further decisions, if there's going to be more data based on the version of the stream or less data, we can just start reading more data, or we know that there's enough data. So this way we can kind of send more data in different versions, but we still know that 7.10.0 will work with 7.9.3 just by adding these kind of checks in our serialization protocol. So the main question we are basically now faced with is, no matter what we do internally, we still have to communicate to the user that there are probably backwards incompatible changes when you upgrade from version 6 to 7, 7 to 8 between major versions. And the main question here is like, how can we do this? So one of the features we introduced in recent Elasticsearch versions was the ability to show so-called deprecations. So as someone developing a software, you always know this is a feature I want to get rid of. This is a feature that is not supported by any of our libraries. So if a user is using this feature, I should probably tell the user in advance that this feature might change, its behavior is going away, that you should replace a configuration parameter. And then the user can do this before the actual upgrade happens. And this is where the deprecation feature in Elasticsearch comes into play. This kind of warnings get basically added to the existing major version so that the user knows about this before upgrading to the next major version. And the way this works in the code is that there's a so-called deprecation logger, which is an extension to an existing logger class. And this deprecation logger contains the message, whatever you provide. For example, in Elasticsearch, the way you divide data is called a shard. And the shard is kind of the unit of scale, if you want. And the default number of shards in Elasticsearch used to be 5 over all the years before version 7. And it turned out that users created a lot of indices, which means there were too many shards. Each shard needs a system resource. And we wanted to change this default behavior. So if you create an index and you don't specify anything, the default number of shards should no longer be 5, but 1. And we did this change in Elasticsearch 7, but in the Elasticsearch 6 branch, we basically added this log message where we told the user, look, you haven't supplied any specific option. By default, the behavior will change in the future. If you want to make sure that you keep this number of shards, you must manage this when you create the index or use an index template. And with this kind of feature, we basically could ensure that the user was aware of this problem. Because the last part that we now had to do is, how do we transport this deprecation logging message to the user? So one of the things, or one of the ways we picked was basically adding this information to warning headers in HTTP. This is one of the features that you can basically use in HTTP, adding a header, and there's a specific RFC about adding warning headers that should just tell you that you probably should look after this request in detail. And you can see here that the response of the request at the top contains a couple of warnings just to tell you, look, the thing that you do, it works as expected, but in the future, the behavior might change. And we also exposed these messages in Kibana, in the so-called Kibana DevTools console. It's kind of a small JSON client within Kibana, allowing you to write arbitrary requests. And we also write this into a log file in Elasticsearch. So in order to figure out if you use deprecated features, you can just check the Elasticsearch log files and see, okay, we are still using that. We should probably fix our behavior. But no one is reading any of these. Like, people started upgrading, ran into problems, asked why they are running into problems. And some people are reading the breaking changes documents, some people are not. But still, there was a lot of time when you could have read this kind of messages and be warned about this, but we found out that people are not too much into reading these. So yeah, what can you do to make users more aware of features changing over time? And we thought about this, and one of the things that we actually came up with was a so-called upgrade assistant for the Elastic Stack 7. So when you go from 6 to 7, we had this upgrade assistant in the UI in Kibana, and you could basically see if your cluster was ready to be upgraded, if there were any issues that needed to be resolved. on the cluster level, on the index level, and on the node configuration level if you want. So you could see there's a tab at the top. There's the overview, the cluster, and the indices tab. The cluster tab basically went through a couple of checks, and we'll take a look at those in a second, for the cluster, and said, look, there's a configuration setting that you need to add in order to make sure that the upgrade is working as expected. The same for indices. So for all the data that you added, we basically go through each of the indices, through each of the index configurations, and take a look, is there anything that is not working the same way as before? And then there is a details tab or a details field where we just say, okay, this needs to change, but there's also a link to the documentation where the user can jump directly and read more about that. There's also, as you can see, the yellow warning sign that we tell the users you should back up your data before you're actually doing your upgrade, just as a precaution. So if we see that there's no snapshot or that there's no snapshot repository configured, we can also warn the user that probably a backup makes sense. So what is this upgrade assistant doing from an Elasticsearch perspective? First, you can do something like re-indexing your old indices. I was already telling at the beginning that Apache Lucene only goes one major version back. So if you already did this kind of upgrade, you probably had indices from Elasticsearch major version 5 lying around. And in order to be able to read those with Elasticsearch major version 7, you need to do a reindex operation in the current Elasticsearch major version 6. So this upgrade assistant allowed you to do that. You could basically just click a button and then the reindex was triggered in the background. Also, Elasticsearch uses a ton of internal indices for its different use cases. Think of the Kibana configuration. Think of user configuration if you decide to store this within Elasticsearch. Think of alerting configurations like for Watcher. And those services also need their index upgraded. Those services probably need a change of mappings, which we can do as part of this internal upgrade process as well. And there would be another button to do all of this for the internal indices, to just pause the services like the alerting service, do all of these changes, and then start them again. And of course, we also could replace the index templates. I just showed you that there's possibly backwards incompatible mappings in user indices that we could warn the user about before doing the upgrade. And we ran this set of deprecation checks to warn you about wrong configuration options. For example, this was applied to cluster settings. If you use the configuration setting that is probably going away in the future, we could warn you about it and say, like, look, if you upgrade, please remove the setting. The same for the node configuration. So each node has a YAML configuration file where you could, again, configure certain things. And these things were checked as part of the configuration. Then for every index, the index configuration was checked as well. And also the machine learning configuration for the machine learning add-on. So it turns out that all of those deprecation checks are nice and already helped a lot, but it's not the full solution. So the next major upgrade assistant within the Elastic Stack will have even more features. And I want to talk about those because this looks like it's a good start and it covers a fair ground. But again, there are more things that you can actually do. So the first thing is those deprecation checks were for Elasticsearch only. And I showed at the beginning, we have a full stack, right? You need to keep your whole application in mind, right? Even if you use several services or several data stores, something like that, you always have to take a look at all of your data stores and not only at a single system. Also, it was only checking the existing configuration. And while that is a great start, because you know that Elasticsearch will start up properly, there may also be features that are you informed about deprecation at runtime, right? If you write a query and that query uses a deprecated feature, you will get a feedback back to the client, but we will not see it in the upgrade assistant. So this is absolutely crucial to also show this kind of information somewhere else and to give an overview what kind of deprecations actually exist that are not about configuration. And in order to fix this, the next step is basically to support so-called stack deprecations within the Elastic Stack. And the idea here is that every component in the stack can write to a dedicated data stream, considered sort of a time-based index if you want, within Elasticsearch. And then Elasticsearch is collecting these kind of deprecations. And using this, you can just open the upgrade assistant in Kibana and go through each single deprecation and see potentially who triggered it, what do I need to change. And when this deprecation log stream at some point is 0, you know that the upgrade itself will work as expected. And of course, the feature that now every component in the stack can basically write to this write this data is really important, right? You don't have to log into any system, take a look at any log file, and see if something is still working as expected. You know everything is collected centrally. You can take a look and see what are my current problems with the different deprecations before I upgrade. So this is a huge step forward. And this is also something that you should consider in your own applications, just like, what can I do to properly collect deprecations to warn my users to change their behavior? And of course, this is just a small side note here. If you say users should upgrade by doing a rolling upgrade, please make sure that this is part of your automated test suite, right? Every CI run of Elasticsearch will mimic a rolling upgrade. Every CI run of Elasticsearch will mimic a full cluster restart by starting an older version, running a set of tests that create some data, shutting both nodes down, bringing the new nodes up, and running the same set of tests again to see if the behavior changed and if the data can still be read that has been written. And the same also applies in the mixed cluster setup, right? When you do a rolling upgrade, you have new nodes, you have old nodes, and you should properly test this. So if you provide different ways of upgrading, make sure they are all part of your CI infrastructure. So I want to talk about a couple of examples, just to give you maybe a better picture of what kind of issues we faced within Elasticsearch. And I think the first one is a common one that you have probably faced in your own applications as well. So you all know Joda time and Java time. Joda time used to be the de facto standard for date handling libraries in Java for a long time. But Joda time only supports millisecond resolution, and it's kind of in a maintenance mode. So it basically only sees time zone database updates. And the JDK got a Java time API over time, which also supports nanosecond resolution. And if you're doing something like in the manufacturing industry, then milliseconds is not granular enough. You really want to go with nanosecond resolution when logging data. And JDK and Joda time are different beasts. They are written by the same person, and you can see that a lot of lessons learned within Joda time were applied for Java time, but you can't compare them. And that's a really important point. For example, I have this small tiny test here where both Joda and Java time use the same time pattern. So you can see formatted patterns here. And the big thing is they are not the same. Like one uses a week-based year and the other one uses a calendar-based or date-based year. And if you run this test, one of those returns 2019 as the current year for this date, for New Year at the last day of the year. And the other one returns 220 because it's already using the week-based year. And this, of course, is a problem, right? Because you would break backwards compatibility if you just did an upgrade and used the same date pattern. So we had to work on that. And the switch from Joda to Java time is basically still ongoing. So in Elasticsearch 6, any date format uses Joda time. And when we found a Joda date format that basically was not compatible with the Java date format, we emitted a deprecation warning. And we added a new prefix starting with an 8 to tell the users, if you want to make sure you use Java time, which I think was introduced in Java 8, that's a reference, please use the date format for Java time with an 8 prefix. And at that moment, when we switched from Elasticsearch 6 to Elasticsearch 7 to the next major version, by default, Java time was used for dates. And if there was still an old date using the 8 prefix, we basically emitted a deprecation warning. And only in 8.0 and onwards, we can basically support or drop support for these 8 prefix date formats. And you can see here that this whole switch already spans over several major versions of the Elastic Stack. So this whole operation will take several years unless we can completely get rid of the Joda dependency. So even a seemingly small switch from Joda to Java time is a major effort in this kind of code bases, especially if you don't abstract away the time handling, which I don't think a lot of tools or libraries do, especially nowadays with a Java Time API, which is directly in the JDK. Another example is the removal of so-called types from indices. So you could basically, for every index, or whenever you index a document, you had to specify an index and a type. So a type was some sort of metadata. However, this metadata could lead to indices being less efficient because you ended up with sparse data if you indexed very different documents into a single index. And we try to tell users they should not do this. So at some point, we decided that indices should only have a single type because it's way better how Lucene works internally. So the way to go here was that in Elasticsearch 5, arbitrary types were supported. And from Elasticsearch 6 onwards, only a single type or an index could only specify a single type. And in Elasticsearch 6, we still needed to be able to read the old 5x indices, right? Because it's only one major version behind. We added a limitation that also new indices with several types could not be created. So whenever there was an index that already had a type, a new type could not be added. And we also added a pseudo type, if you want, to basically keep the URL stable, where you had to specify a type in the URL. So you had some sort of placeholder. So in Elasticsearch 7, those indices do not have any type at all, but you still have the URLs which contain this pseudotype. Part of those APIs are now marked as deprecated, so users tend to switch when the next major version of Elasticsearch comes. And only in Elasticsearch 8, we can basically remove these types. So again, this is a really long list of steps across several major versions where the releases span several years. So this is a major effort. And the next thing we have to keep in mind is that when clients switch from 7 to 8, we probably still want to make sure that the old URLs are working. So this is why there's something like a REST API version compatibility being worked on right now. Because this REST API, it's a main communication interface for all the clients. Whenever you break something there, it has severe effects to all of your users, right? Because this is not an internal thing to do. And this means that major version upgrades could break endpoints or the request structure. And in order to eat this, we want to make sure that upgrading all clients still doesn't need to be dependent on Elasticsearch itself. And this means that maybe we will end up with a REST API version compatibility that allows for types, even despite they not being existing more in the code base. And that's a crucial feature to just make sure you have this layer of backward compatibility. Lastly, I have a couple of minutes left, so let's talk about a couple of strategies. What can you do to basically figure out these kind of exceptions? What can you do to warn your user? And for example, the Elasticsearch Java REST client has a really nice feature. It's called set strict deprecation mode. And it's something you would not set in production, but for example, in your CI. And the moment this feature is set, the Elasticsearch request that has been sent to Elasticsearch that contains one of those warning headers or one of those deprecation messages I talked about at the beginning means that the whole request will fail, which is something you don't want to have in production. But if you enable this in your CI infrastructure, you will see failing tests because you're still using deprecated features. So you can fix those features on the existing major version and know that everything works as expected by just setting this feature in your CI. And if you want, you can also set this in production the moment you're planning your upgrade to make sure everything works. And I think this is a great strategy to get notified early about deprecations when you're using the Java HTTP client. Another strategy is reindexing from remote. So when you upgrade, for example, from Elasticsearch 2 to 7, so we had to release Elasticsearch 2, Elasticsearch 5, 6, and 7. This would basically require 2 reindexing steps to go from 2 to 5, from 5 to 6, so that you could still read the data with Elasticsearch 7. Reindexing is rather I/O and CPU heavy, so you would try not to do it twice. And one of the possible solutions here is to use a feature called reindex from remote, where you could point the Elasticsearch 7 instance to reindex the data from the Elasticsearch 2 index via HTTP and just do a so-called scroll search and do a batch index of this data. So you would only have to reindex it once. And I think that's a really good feature to circumvent this kind of problem. And you have a one-time indexing cost, and you can also do scripting, which basically means that you can change the data if you need to. If you still would need to remove types, that would be possible. So you have some sort of processing capabilities before the new document is stored. Another strategy here would be to replace clusters over time. So what I mean here is that if you have something like time series data, the classic logging use case, you're collecting logs from all of your systems, then those logs tend to get less important over time, right? You usually try to create dashboards for the last 7 days, for the last month. You rarely look up back in time for the last 12 months of how your traffic was there. So this means that if you have something like an old major version logging cluster, you could try and just add a new major version logging cluster next to it, index all of your data in there, and when you do a query, you just query both clusters using a feature called cross-cluster search. And cross-cluster search allows you to query both clusters, get back the results as if this was one cluster, and then use them in Kibana or wherever you want. And this way, you don't have any stress with reindexing your data, because you can just age out the data over time, and then at some point in time, shut down the older cluster. One of the nice features of cross-cluster search is that you basically can query 3 different major versions. If you hit a Elasticsearch 6 instance, you can query one major version down, one major version up. And this means you can get data from 3 major versions. So given the release cycle of Elasticsearch, this means you can query many years of data if you want. And yeah, at some point, the old cluster can be shut down if at some point you just don't need this data anymore, and you can remove it. One last example, and then we can go to the summary. Sometimes you need to remove a feature, and it's hard because in the case of Elasticsearch, there was a feature in Elasticsearch 1 called delete by query, where you could specify a query, and all the documents that matched this query were deleted. Really useful feature. However, at some point, we figured out that shard copies, which should always hold the exact same data, could basically diverge when this feature was used and a couple of other circumstances happened at the same time. And that was unacceptable. Like, one of the most important parts of Elasticsearch, even back then, is that your data is safe. So this functionality got removed immediately with the next release. And of course, the user reaction was like this. Users were upset, like, why did you delete this feature? It always worked for me. This is really bad. And now I can't use your product anymore. And I mean, they were right at some point, right? We deleted a really useful feature. So what did we do? We documented all the steps to achieve this in a safe way via existing APIs. And then we added the required infrastructure to re-implement this feature in a safe way. And one of the required infrastructure was the support for long-running tasks within an Elasticsearch cluster. And after this had been added to the next major version, we basically implemented delete by query using those long-running tasks. And now it works safe and as we would expect it to run in a safe manner. So this is also something you probably have to deal with, and which means that suddenly your software is not backwards compatible, maybe sometimes only for a short amount of time. But if it's about the safety of your software, it probably is a wise decision to get rid of these kind of features. So let's go to the summary then. One of the things is, if you don't provide, or if you don't have backward compatibility, it basically means that you will have to provide maintenance forever for your products, right? Because users don't upgrade, and users still expect fixes, corrections, and they don't want to invest a lot of work of keeping your system up to date. You need to prepare users to tell them, like, look, what happens? This will happen when you upgrade. This will not work as expected anymore. We added those deprecation warnings for this. You need to provide some sort of migration path, like also documentation of how to go there. What can you do? Can you do rolling upgrades? Can you do a parallel shutdown? These kind of things. You need to be really good with documenting breaking changes. Elasticsearch has a really long list, or a really long couple of documents that you have to read in order to be aware. Most of the time, only a very small fraction of this affects you because you're not using all of the functionality, but it's still crazy important to take a look at those things. And if you decide to get rid of something, if you decide to change something, like, don't try to cram things into major versions and break things. even if it's a lot of work, if you have the ability to stretch this over several major versions, but allow for a more smoother upgrade from a user perspective, always strive to go for that option. And yeah, if you remove functionality, like make sure there's a pass to tell users like, look, you can do this instead, even if it means more work on the user side. Like removing functionality and not providing any guidance, of course, is always an issue. And a general term, if you add functionality, if you add a feature, if you merge a pull request in your open source project, you own this feature, right? And this is important because if there's no feature, there won't be future backwards compatibility issues. So you have to decide, is the cost of adding this feature, is the cost of ongoing maintenance worth it? Or do you have the ability to create a plugin, for example, and let your users handle this kind of feature? It's an important thing to think about, providing infrastructure for others to own things, or if you take a piece of source code and put it into your own product. Like the cost is not merging a PR, the cost is always maintenance. And yeah, one of the most important things is ask your users where are the biggest issues with upgrades, right? And in the past, in the early Elasticsearch days, the big issue was, oh, we have to shut down our whole cluster, but I'm indexing a lot of logging data in there. Like, what can I do? How can I keep the data as long as I'm doing this upgrade? These kind of things. So these major migration pain points is something that you have to take a look at to figure out, like, where do you get the biggest effect when you ease the upgrade? And of course, if you are in the lucky business of software as a service, you usually have the option to kind of offer one-click upgrades. So you make it really easy for the user. And this way, users only have to prepare their applications. Like in Elastic Cloud, you pretty much can select, oh, there's a new version. I really would like to run that. Of course, this still means you have to make sure that your client doesn't use deprecated features. But just offering this ability is really, really important to make sure that everyone can use the software and also upgrade. If you make the upgrade experience easy, you will have to deal way less with older versions that you have to maintain forever. And you also have to come up with a policy to say, at point X, we will not support this version, and be strict about this policy, because otherwise people don't have another motivation to upgrade. All right, this is my last thought that I would like to leave you with. I think it's really, really hard to put a cost stamp on these kind of things. This is also why people don't like to talk about it, because it's hard to quantify the cost of backward compatibility, right? We have this very common example of supporting Internet Explorer 6 in our head. Like, what does it cost? How much time do we need to invest? But we rarely do it for the rest of our stack. And I would like to have everyone keep this in mind, that like backward compatibility comes with a cost. It comes with additional code. It comes with additional reviews. So you need more manpower. And can you quantify this? I think it's a great question. And I don't have a definitive answer for this, but I also think that this is very different on all the use cases that you have and how you have to maintain software. So there's one dedicated question here. Did you have similar challenges with different JDK versions? And that's an absolutely valid point, because we indeed had. Elasticsearch ships with a JDK. This just makes it simpler for non-Java users to get up and running. On top of that, we had JVM bugs. For example, the handling of dates in certain JVM versions is different. You have to add another parameter to make it the same between Java 8 and Java 11, I think. So we have to decide on startup how we do this. So yeah, we did have challenges. They are not as common and relatively rare. It's not about different, it's about different JDK versions. It's not so much about different JDK distributions. So far, most of those were pretty okay if they are based or evolving around OpenJDK. In which case do you suggest to make updates, upgrades? Yeah, I have this one slide where I kind of was sorting this by motivation regarding security. For me is always the biggest priority. I'm really keen of making sure that the users or the data in my Elastic Stack cluster is as secure as possible. But the other thing is usually bug fixes. You want to make sure that your Elasticsearch cluster is stable, works as expected, but also performance and memory consumption, doing less at the same time. These kind of things is something that, at least in the Elasticsearch case, you usually get this for free by just upgrading. And we usually try to move performance only in one direction, not get slower. So I think those are the most common points where we as developers or we as providers of software can go to users and customers and then look, you should upgrade because otherwise it's going to be really, really hard. You have to give users of your software reasons for upgrading. Otherwise, it usually gets next to impossible to get users to upgrade at all. And that also would mean there's the perfect software, which I would not think it exists. Okay, there's the face. I'm not sure what you're referring to as face here. Is it more when you would like to upgrade in terms of within your application, or when you would like to upgrade when there's a new software out? I'm not sure I'm fully understanding the face question here. Okay, you got the answer. That's great. Thanks again for having me, and have a good day, everyone.